Once again, welcome you to GK's maths classes. Today, in continuation of differentiation, we are going to do the next part of it, that is the higher order derivative. Okay, this is a part 6 of the video. Previously, I think we did implicit function, we have done logarithmic functions differentiation. Now we are going to do higher order derivative. Okay, so let's straight away get inside the problems. Now these are the formulas that I always give you, so you can always keep a note of these formulas, they are very useful to you. Now what is a higher order derivative? Now you know, for example, if you have y equal to say sin x, when I differentiate this for the first time, dy by dx, you get cos x. So this is called first order derivative. First order derivative. It is also denoted as y1. You can also write it as y dash. You can also write it as f dash of x. This comes under first order derivative. So where I differentiate for the first time. Now if I differentiate this second time, that is d by dx of dy by dx. You know, d by dx is the differential operator. So when you operate the differential operator second time on dy by dx, I will get d square y by dx square. D square y by dx square, which in this case it is say minus sin x. And it is generally denoted as y2. You can also write it as y double dash, or you can say f double dash of x. So this is called second order derivative. So if you want to differentiate this once again, you can do d by dx of, we don't have this, but still I'll just mention it. It will be d cube y by dx cube. So this is a third order derivative. So first order derivative means differentiating a function only once. Second order derivative is differentiating the dy by dx again, or differentiating the y 2 times. Third order derivative is differentiating a function 3 times. Okay, so I think that is clear. Now let's do some problems. Now I have a question. I will be doing questions from NCERT as well as from board papers, so that will be a compilation of second order derivatives. So the first question is y equal to sin inverse x. Prove that d square y by dx square equal to x by 1 minus x square the whole power 3 by 2. Now how do I do it? So first let's take y equal to sin inverse of x. Now differentiate both sides with respect to x. So what do I get? dy by dx, this is the first order. And differentiation of sin inverse of x is 1 by root of 1 minus x square. Differentiation of sin inverse x is 1 by root of 1 minus x square. Now what I should do? I have to do second derivative. So can I say dy by dx is 1 minus x square whole power minus half. I take this up. Again differentiating with respect to x. So when I differentiate dy by dx, what do I get? I get d square y by dx square equal to, now I'm going to use chain rule. So first I differentiate the power. What is that? Minus 1 by 2 into 1 minus x square the whole power minus 3 by 2. Minus 1 by 2, 1 minus x square the whole power minus 3 by 2. Now the base, the differentiation of 1 is 0. Differentiation of minus x square is minus 2x. 2 gets cancelled. And minus of minus is plus. So I get x by 1 minus x square the whole power 3 by 2. So very simple, straightforward question. It's not at all difficult. I hope this is clear. Okay. Now let's go to the next question. Now how do I do this problem? Okay, here y equal to cos of nx b into sine of nx. I have to prove this result. So first what I will do, I'll take y equal to a cos nx plus b sine nx, and I call this as 1. Let it be there. Now I am going to differentiate both sides with respect to x first time. Okay, so first order. So dy by dx will be, a is a constant, differentiation of cos is minus sine nx, and differentiation of nx is n, plus b into, what is the differentiation of sine nx? It is cos nx into n, chain rule. First I differentiate cos, then I differentiate nx. Differentiation of nx is n. Okay. So now you have got dy by dx is equal to minus a n into sine nx plus b n into cos nx. Once again I differentiate. Again I differentiate with respect to x. So what is differentiation of dy by dx? D square y by dx square equal to minus a n is there. What is the differentiation of sine nx? It is cos nx into n plus bn into, what is differentiation of cos nx? Minus sine nx into n. Now if you observe this carefully, minus sign is common, n square is also common. Can you see n into n? N square is common. So what are you left with? A cos nx plus b sin nx. Now from 1, look at equation 1. From 1, a cos nx plus b sin x is given as what? Dx square equal to minus n square, this will be y. Now if you bring it to the other side, you get d square y by dx square plus n square y equal to 0. Hence proved. Okay. Now coming back to the next question. Y equal to, you have given y equal to a cos of log x plus b sine of log x, which I will call it as 1. I need to prove this result. I have to prove x square d square y by dx square plus x dy by dx plus y equal to 0. Now how do I do it? First I differentiate. Dy by dx. A is a constant, let it be there. What is the differentiation of cos? Minus sine log x. And what is the differentiation of log x? 1 by x plus b into, what is the differentiation of sine of log x? Cos of log x. And what is the differentiation of log x? 1 by x. Now you cross multiply x. X is the LCM which can be cross multiplied. So x into dy by dx is what? Minus a sine of log x plus b cos of log x. Now again I will differentiate both sides with respect to x. Now how do I differentiate x into dy by dx? I have to use product rule. This is u and this is v. So what is product rule? U into, what is differentiation of dy by dx? It will be d square y by dx square plus v. What is v? Dy by dx, and differentiation of u will be 1 equal to minus a. What is the differentiation of sine? It is cos of log x, and differentiation of log x is x minus b. Why did I put minus? Because differentiation of cos is minus sine and differentiation of log x is 1 by x. Now clearly x is the LCM which can be cross multiplied. So when I cross multiply x, what will happen? You will get x square d square y by dx square. So first I multiply this x with this, so x into x is x square. Then again plus x into dy by dx, because I am cross multiplying. Remember this x will be common to both the terms. And here if you notice minus sign is common. So I get a cos of log x plus b sine of log x. Now clearly from 1, a cos log x plus b sine log x is what? It's 1. So I will say from 1, this will become x square d square y by dx square plus x into dy by dx, this becomes minus y. So if you bring the y this side, what do you get? You get x square into d square y by dx square plus x into dy by dx plus y equal to 0. So this is exactly what I wanted to prove. Very, very simple question. Okay. Now let's go to the next one. Now this is a very nice problem. You get y equal to tan x plus secant x. And I need to prove that d square y by dx square equal to what? Cos x into cos x divided by 1 minus sin x the whole square. So what I do here is first I differentiate. So first I will differentiate. How do I differentiate? Dy by dx. And what is differentiation of tan? Tan is secant square x. And what is differentiation of secant x? It is secant x tan x. Now since the answer is in terms of sine and cos, I will convert everything to cos and sine. Cos secant square is 1 by cos square. Secant is 1 by cos. Tan is sin x by cos x. So cos into cos becomes cos square. Now if I take LCM, LCM is cos square x. So I get 1 plus sin x. But clearly this is cos square x is 1 minus sin square x. So 1 square minus sin square can be written as, I am using a square minus b square. So it is a plus b into a minus b. So clearly these two gets cancelled. So what is my dy by dx? So my dy by dx is 1 minus sin x the whole power minus 1. 1 minus sin x the whole power minus 1. I take this up, okay, because this is power 1. I take it to the numerator. Now differentiate. Once again, so this is second order derivative. D square y by dx square equal to minus 1 minus sin x whole power minus 2. I am using power. First I differentiate the power. Now I differentiate n into x power n minus 1. Now I differentiate the base. Base differentiation is 1 is 0, minus sin x is minus cos x. So minus into minus is plus. So I get cos x divided by 1 minus sin x the whole square. This is exactly what I wanted to prove. It's very simple and it is an important question also. Now the next one. Very, very, very important question. It has come in the board exams also. So you have y equal to x into log of x by a plus bx. I wanted to prove x cube into d square y by dx square equal to x into dy by dx minus y the whole square. So what do I do? So the first step here is the most important step. Bring the x down. Y by x. So I will get log of x by a plus bx. So the next step will be, you write log m by n is log m minus log n. Okay. Now you go for differentiation. Differentiate with respect to x. Now here you can see clearly I have to use quotient rule. Y by x I have to use quotient rule. What is quotient rule? Denominator square, denominator into, what is differentiation of y? dy by dx minus y, differentiation of x is 1 equal to, now what is differentiation of log x? 1 by x. And what is the differentiation of log of a plus bx? 1 by a plus bx. So first I differentiated log. Now I am going to differentiate a plus bx. A differentiation is 0. Bx differentiation is b. Okay. So now you have got x into dy by dx minus y by x square equal to, what is the LCM? Your LCM is x into a plus bx. So what do you get on the numerator? A plus bx minus bx. So they get cancelled. Now clearly you can see x and x gets cancelled. So you're left with what? X into dy by dx minus y equal to ax by a plus bx. How did I get ax? I got ax because I cross multiplied this x. And I call this equation as 1. Because I need it, I will be using it. Now again what you do, differentiate with respect to x. Second order derivative. Now here you have to use product rule. Now how do I use product rule? U into, what is differentiation of y? Differentiation of y is d square y by dx square plus dy by dx into, what is differentiation of x? Differentiation of x is 1. U into v dash plus v into u dash minus, what is differentiation of y? Dy by dx. Now here I have to use quotient rule. How do I do quotient rule? A plus bx the whole square, a plus bx. What is differentiation of u? Differentiation of ax is a minus u into, what is differentiation of a plus bx? Differentiation of a is 0, differentiation of bx is b. Now clearly you can see these two gets cancelled. Now you have got x into d square y by dx square equal to, if you simplify this, if you open the bracket, bxa gets cancelled. So you are left with a square by a plus bx the whole square. But if you observe the answer is x cube, but I have only x. So what I do, I multiply both sides by x square. If I multiply both sides by x square, what will I get? I will get x cube into d square y by dx square equal to a square x square divided by a plus bx the whole square. Now look at 1. From 1, look at 1. 1, a square x square by a plus bx whole square will be what? Will be x into dy by dx minus y the whole square, correct? Ax by a plus bx is x into dy by dx minus y. Since this is whole square, this will also be whole square. And that is exactly what I wanted to prove. Very simple and very important question. Okay, the next one. This is also a very important question. You are given y equal to log of x plus root of x square plus a square. And I need to prove this. Now what I do, first I differentiate. I differentiate with respect to x. Now how do I differentiate y? Differentiation of y is dy by dx. Now how do I differentiate log of anything? So first I differentiate log, which is 1 by x plus root of x square plus a square. I'm using chain rule, into, I have to differentiate the base. Differentiation of x is 1, then I see the root. Differentiation of root will be 1 by 2 root of x square plus a square. Then I go inside. Differentiation of x square will be 2x. Of course, differentiation of a square is 0 because it's a constant. So first I differentiate log, then I differentiate x, then I differentiate root, then I differentiate x square. Okay. Now 2 and 2 can be cancelled. So what you are left with? Root of x square plus a square. Now what is the LCM? The LCM is root of x square plus a square. So what do I get up? I get root of x square plus a square plus x, correct? Now this is exactly same, so they get cancelled. So what is my dy by dx? my dy by dx will be 1 by root of x square plus a square. I need to prove this. Okay, so what I do, you can directly differentiate, but the easier thing is cross multiply. First you cross multiply. Then you get rid of the root by squaring both sides. So you square both sides. When you square both sides, what do you get? X square plus a square. There are some students who make a mistake that when they square dy by dx, they write d square y by dx square. That is not correct, so don't do that. So if you square dy by dx, you will get dy by dx whole square, nothing else. Okay? And differentiation of 1 will, square of 1 is 1. So I got rid of the root because root is always uncomfortable. Now again I differentiate. U, V, product rule. How do you use product rule? X square plus a square u into, I want to differentiate b. How do I differentiate b? First you differentiate the power. What is the power? 2. 2 dy by dx to the power 2 minus 1. That is 1. So I differentiated the power. Now go inside. Differentiation of dy by dx. What is that? D square y by dx square. This is chain rule. I am using chain rule for dy by dx whole square. Plus v. What is v? dy by dx the whole square. And what is differentiation of x square? Differentiation of x square will be 2x. And of course differentiation of a square will be 0. And differentiation of 1 will also be 0 because it is a constant. Now if you observe carefully, 2 is common, so I can cancel it. dy by dx is common, so it can be cancelled. So what is left out? X square plus a square into d square y by dx square plus x into dy by dx equal to 0. This is exactly what you need to prove. Is it clear? Now let's go to the next question. Now watch this. This is something similar to the previous problem. Okay. This is x plus root of x square plus 1 whole power m. And I wanted to prove x square plus 1 y2. y2 means d square y by dx square. X y1. y1 means dy by dx minus m square y equal to 0. This is what I need to prove. So I will differentiate this. dy by dx. How do I differentiate? First I differentiate the power. How do I differentiate the power? M into x to the power of, this is the entire term is x to the power of m minus 1. M x power m minus 1. So I differentiated the power. Now chain rule. Go inside. Differentiation of x is 1. Then root. What is the differentiation of root? 1 by 2 root of x square plus 1. Then go inside. Differentiation of x square will be 2x. So it's chain rule. First I differentiate the power, then I differentiate x, then I differentiate root, then I differentiate x square, then I differentiate 1. 1 differentiation is 0, so I'm not writing it. So they can be cancelled. So what you're left with? M into x plus root of x square plus 1 the whole power m minus 1. Now take LCM. If you take LCM, I get x plus root of x square plus 1, correct? I wrote this first because a plus sign by root of x square plus 1. This is power 1. Now you know x power m minus 1 into x power 1 is x power m, correct? When the powers get added, the base is the same, so powers will get added. So what are you left with? M into x plus root of x square plus 1 whole power m divided by root of x square plus 1. Now I call this as 1. Now from 1, what do you know? From 1, this is actually dy by dx. I cross multiply this, so I can avoid one step. X square plus 1 into dy by dx equal to m into y. Because x plus root of x square plus 1 whole power m is y. Now as usual, I want to get rid of the square root. How do I get rid of the square root? Squaring both sides. Squaring both sides. So what do you get? X square plus 1 into dy by dx the whole square. Don't forget this. Don't write it as d square y by dx square while squaring. Equal to m square y square. Now again differentiate. Differentiate with respect to x. I am going to use product rule. Now what is product rule? U into, what is differentiation of dy by dx whole square? 2 into dy by dx. First differentiate the power. I differentiated the power. Now I am going to differentiate the base. What is differentiation of dy by dx? D square y by dx square plus dy by dx the whole square, and differentiation of x square plus 1 will be 2x. Again I will repeat, chain rule. U into differentiation of this. First you differentiate the power, then you differentiate the base. Plus v into differentiation of x square plus 1 is 2x. Equal to m square is a constant. What is differentiation of y square? Chain rule. First you differentiate the power. 2y. Okay? 2y. Then you differentiate y. What is the differentiation of y? dy by dx. I hope this is clear. Now clearly you can see on both sides 2 is common. And on both sides dy by dx is also common. So what you are left with? You should not get confused with this. What you are left with? You are left with x square plus 1 into d square y by dx square plus x into dy by dx equal to m square y. Bring that m square y this side. It will become minus m square y equal to 0. This is exactly what you need to prove. It's so easy, isn't it? Follow the procedure. Make sure you use product rule correctly, use the chain rule correctly, you will get the answer. Now, very, very important question. Okay, y equal to sine of sine x. I will just call this as 1. Remember, it is sine of sine x. Here sine x is the angle for sine. Okay, so it's one single function. So don't use product rule. Many students use product rule and get confused. So I'm differentiating dy by dx. So I'm going to use chain rule. What is chain rule? First I differentiate sine. What is the differentiation of this sine? Cos of sine x. Then you go inside. What is the differentiation of sine x? It is cos x. Okay. Now again you differentiate with respect to x. Remember, differentiation of dy by dx will be d square y by dx square. And here, product rule. This entire thing is u, this is v. So how do I use product rule? u into, what is differentiation of cos x? Minus sin x plus v into, v is cos x into, now I want to differentiate this. Now again, differentiate cos. Chain rule. Sine of sine x. First I differentiate cos, which is minus sine of sine x. Differentiation of cos is minus sine of sine x. Then the base. What is the differentiation of sine x? It is cos x. I hope that's clear. Okay. Now I call this as 2. Now from 2, watch this. From 2, look at this. From 2, okay, see what I have circled. D square y by dx square equal to cos of sin x will be 1 by cos x into dy by dx. Can you see that? Cos of sin x will be 1 by cos x, I'm bringing this cos x down, 1 by cos x into dy by dx, and already I have minus sin x. Plus, actually it is minus, why? Plus into minus is minus. What is cos into cos? Cos into cos is cos square x. And what is sine of sin x? From 1, it is y. Okay? So now what happens? D square y by dx square bring this term this side. So minus will become plus. What is sine by cos? Sine by cos is tan x into dy by dx plus cos square x into y equal to 0. That's exactly what you wanted to prove. It's so simple. Okay? Just follow the procedure. Just observe things carefully, you'll get the answer. Now this is again a very, very important type of question. Y equal to sine inverse x the whole square. Okay, now how do I differentiate? Dy by dx. First to differentiate the power. What is the power? The power is 2 sine inverse x. Then you differentiate the base. Sine inverse x is 1 by root of 1 minus x square. As usual, I don't like this square root, so get rid of it. How do I get rid of it? First I cross multiply. And to get rid of the root, I square both sides. So when you square both sides, what do you get? 1 minus x square into dy by dx the whole square equal to 4 sine inverse of x the whole square. Now from 1, this is 1, from 1, what do you know about sine inverse of x whole square? It's y. Okay, now differentiate. This is u, this is v. I'm going to use product rule. How do I use product rule? U into, I want to differentiate dy by dx whole square. How do I do it? First I use chain rule. 2 into dy by dx. First I differentiate the power, then the base. What is differentiation of the base? D square y by dx square. I differentiate the power, that is 2 into dy by dx, and differentiation of dy by dx is d square y by dx square. Plus v. What is v? dy by dx the whole square, and differentiation of 1 minus x square is minus 2x. Because differentiation of 1 is 0, minus x square is minus 2x. Equal to 4 into differentiation of y will be dy by dx. Now clearly you can see 2 is common throughout. This will become 2. dy by dx is common throughout. So what are you left with? 1 minus x square into d square y by dx square minus x into dy by dx equal to 2. Bring the 2 this side, get minus 2 equal to 0. Isn't this what you have to prove? Now the last problem for the day, okay, last problem, y equal to x power x, very, very important type, okay, y equal to x power x. Now variable raised to the power of variable. If it is variable raised to the power of variable, I have to take log on both sides. So log y equal to x log x. Now differentiate. What is differentiation of log y? Chain rule. 1 by y into dy by dx. So first I differentiate log, then I differentiate y. Now here I use product rule. U into 1 by x. Already we have done this under logarithmic. And then v into differentiation of x is 1. So now what is dy by dx? dy by dx will be y into 1 plus log x. Just I'll keep this as 2. I may require. Again I differentiate. d square y by dx square, second order derivative, which is u into, what is differentiation of 1 plus log x? 1 by x, because 1 differentiation is 0, log x is 1, plus 1 plus log x into, what is differentiation of y? dy by dx. Now if you actually observe the answer, in the answer you don't have 1 plus log x, so I have to get rid of 1 plus log x. So what I do is, from 2, look at this, from 2, look at 1 plus log x, look at 1 plus log x. So from 2, what happens? I have d square y by dx square equal to y by x plus, what is 1 plus log x? 1 plus log x will be 1 by y dy by dx, 1 by y dy by dx into dy by dx, correct? So this will be d square y by dx square minus 1 by y dy by dx the whole square minus y by x equal to 0. This is exactly what I need to prove. Very, very, very important type of question. I hope you have understood all this. If you have any doubt, do not hesitate to put your doubt in the comment section. I will definitely get back to you. Kindly subscribe to my channel and also click the bell icon to get notifications. Have a lovely day. See you again in the next video. Bye-bye.